Hello students, so we will start our third video. Okay. Chapter 1 Physics, Class 8. So in the previous video we have learned about the fundamental units, derived units, okay, and some guidelines which we follow to write the units. Fine. So we will study, so our topic will be, today's topic will be our system of units. System of units. Fine. Okay. The fundamental units. In the fundamental units, I have said that these are the units which can neither be derived from any other units, or neither it can be broken into any basic things. Okay, these are our fundamental units. Fine. So in the system of units, we generally follow two type of systems. Okay, the first is our CGS system. The first one is our CGS system. Here our C stands for, okay, C stands for centimeter. In short, this is the unit of length, because usually we measure the length in terms of centimeter or meter. Okay, but in CGS system, here C will represent for centimeter, then G will represent for gram, GRAM. So this is the unit of mass. And the last one, S stands for second, and this is the unit of time. Fine. And the second system is our MKS system. MKS system. Here our M, this stands for meter, and this is the unit of length. So you can see the difference in CGS and MKS. So in CGS system, we use the unit centimeter for measuring length, whereas in MKS system, the standard unit will be our meter. We use meter to measure length. And similarly, K stands for kilogram. Okay. K stands for kilogram. In short, it can be written as kg. Okay. So this is the unit of mass. Again, we have one difference. In CGS system, for measuring mass we use gram, whereas in MKS system, to measure mass we use kilogram or kg. Okay. But S is common to both. S is second. We use second to measure time. Only centimeter, the unit of length and unit of mass is different in CGS and MKS system, and for the time it is same. Okay. However, we have another system, that is SI system. Okay, SI system. So its full form is Standard International System. Okay, so in this system, okay, if we write the in this system, the units of length, mass and time are same that of MKS system. Okay, so in this system, in SI system, the unit of length, mass and time are same as that of our MKS system. Are same as that of MKS system. Its unit, MKS and SI, the units are same. However, it is an enlarged system. It is the we can say the enlarged system encompassing all fundamental units. That means it covers all the fundamental units. Okay, and we will see the SI units of some quantity. I will do this in the next slide. Okay, SI system of units. SI system of units. So you can see this in page number 3. Okay, so if we see some quantity, okay, and their unit and the symbol. So first quantity is our length. So in SI system, the unit of length is meter, and the symbol used for meter is small m. For mass, we use kg or kilogram, and the symbol is kg, small k, small g. Then for time, we use second. It is represented by small s. And to measure temperature, we use Kelvin. Unit is Kelvin and it is written as capital K. Fine. Then we have luminous intensity. So the unit is candela. Its symbol is small c, small d. Okay. Next we have electric charge. So you have to by heart this table. Its unit is coulomb. We use capital C. Then we have current. It is ampere and its unit symbol is capital A. Then amount of substance. Amount of substance we use, the unit is mole and it is written as small m, small o, small l. Then angle. Angle means your 30 degree, 0 degree, 180 degree, 90 degree. That type of angle. In SI unit, it is measured in radian. Okay. Then we can convert it into degree also. 0 degree, 10 degree. In general, its SI unit is radian. Okay. And it is written as small r, small d. And the last one is our solid angle. It is steradian. In the next videos, we will clear about the difference between the angle and the solid angle. We will get this. Okay, and it is written as small s, small r. So you need to remember all the units and their symbols. This may ask in your boards also. Okay. Next we have some definition of MKS unit. Okay. Definition of MKS system, that is meter, kilogram and second. Okay. So generally we have the first definition is for M we have meter. Okay. So meter. So if we see the definition of meter, it is the 1/10 million part of distance from the pole to the equator. Okay, I think all of you know the pole and the equator. Okay, so it is the 1/10 million part of a distance from the pole to the equator, and that distance is known as our meter. It is 1/10 millionth part of distance from the pole to the equator is called meter. and this distance is marked between the two parallel lines and drawn on the platinum iridium bar. Okay, and this bar is kept at a constant temperature in the International Bureau of Weights and Measures at Civits near Paris. Okay, and on October 14, 1960, the General Conference of Weight and Measures changed standard meter length to atomic constant, which does not change with time. That means in 1960, standard meter length is changed to atomic constant and it does not change with time. Okay, fine. So in the book there is another definition, 1 meter. Okay, so you write it down in your copy. 1 meter is defined as 1650763.73 times the wavelength of a specific orange red spectral line in emission spectrum of krypton 86. Okay, fine. Now there are some notations or conversions you need to know, multiples of meter. Okay. So first one is 1 decameter. 1 decameter, or we can write DAM, decameter. It is equals to 10 to the power 1 meter, or we can say it is 10 meter. 10 meter is known as 1 decameter. Okay, then we have 1 hectometer. Okay, it is written as small m, small h, small m. It is 10 square meter. 10 square means 10 into 2, 10. That is, it will give you 100 meter. So 100 meter is known as 1 hectometer. Then we have 1 kilometer. In short, km. It is 10 to the power 3 meter, or we can say 1000 meter equals to 1 kilometer. Okay. Next we have some smaller submultiples. Okay, the negative powers of 10. These are all the positive powers of 10. Then we have again the negative powers of 10. So that starts with our number 1. If we say 1 decameter, it is decimeter. Don't be confused with the decameter and decimeter. Okay, to 1 decimeter, it is written as dm. So it is 10 to the power minus 1 meter. So it is equivalent to 1 by 10 meter, or if we convert it into centimeter, we will get 10 centimeter. That is 10 centimeter is equals to 1 decimeter. Next we have number 2, 1 centimeter, or small c small m. 1 centimeter means 10 to the power minus 2 meter. So if we convert it, we will get 1 centimeter. Next we have our 1 millimeter. 1 millimeter, small m, millimeter. This is our 10 to the power minus 3 meter. So if we convert it into centimeter, this will give us 0.1 centimeter. Similarly, we have 1 micrometer. So it is written as mu. This symbol is known as mu meter, micrometer. So it is 10 to the power minus 6 meter, or if we convert it into centimeter, this will give us 10 to the power minus 4 centimeter. Next we have 1 nanometer. It is nm. N represents nano, m represents meter. So this will give us 10 to the power minus 9 meter, or we can say it is equivalent to 10 to the power minus 4 centimeter. That means if we convert the meter into centimeter, we have to multiply by 100. And last one is our 1 picometer. That is pm. It will be 10 to the power minus 12 meter. So if we convert into centimeter, we will get 10 to the power 10 centimeter. Fine. So we have got the definition of meter. Next we have the second definition, that is our kilogram. We are studying the definition of MKS unit. Okay, so second one is our kilogram. Fine, kg. So we can define the kilogram as when a force of 1 Newton, when a force of 1 Newton produces an acceleration of 1 meter per second square in a body, then the mass of body is said to be 1 kilogram. That means suppose we have one body, suppose we apply a force of 1 Newton. Then after applying a force of 1 Newton, if the acceleration of body is 1 meter per second square, then the mass of that body will be known as our 1 kilogram. Okay. Now we have some multiples of kilogram. That means first one is our 1 quintal. I think many of you have heard this. We use this as a multiples of kg. 100 kg, 200 kg, 300 kg, 1000 kg. For this we use these terms. 1 quintals, or it can be written as small q, small t. 1 quintal means 100 kg, or we can write 10 square kg, or you can also write 100 kg. 100 kg means 1 quintal. And the second one is 1 ton. We use this units for measuring heavy body. Okay, so 1 ton, TONNE, that is small t. So this is 10 to the power 3 kg. This will be 1000 kg. So generally we measure, we use ton to weight for elephants or rhinos, because their weights are in ton. Okay, fine. Then we have again the sub units of kilogram. That means the negative powers. Okay, so for the negative powers we use 1 hectogram. These are the units which are measured for less heavy. Okay, which are generally in grams. Okay, so we have 1 hectogram, or we can write it is Hg, hectogram. This is our 10 to the power 1 minus 1 kg, or if we convert into kilogram or gram, it is 100 gram. 100 gram is equivalent to 1 hectogram. Then we have 1 decagram. It will be DAG, symbol will be DAG. So this will be 10 to the power minus 2 kg, or we can say 10 gram. 10 gram is equivalent to 1 decagram. Now the further if you move, third one, it will be our 1 gram. 1 gram is simply 1 gram, or we can say it is 10 to the power minus 3 kg. It is written as 1 gram. And fourth one, it is 1 milligram, mg. It is 10 to the power minus 4, or not minus 4, milli. Milli means 10 to the power minus 6. Already discussed in terms of meter. Okay, 10 to the power minus 6 kg, or we can say 10 to the power minus 3 gram. In terms of gram, it will be 10 to the power minus 3. And similarly, last one we have microgram. It will be mu g. For micro, we use 10 to the power minus 9, or this will be 10 to the power minus 6 gram. And the last unit of MKS system was our time. Okay, so how we will define the time? It is the interval between two events. Okay, it is the interval, or we can say the interval between two events, any two events. Okay, suppose the first event it started from some time and it suppose ended at the some time. Okay, so if you differentiate that or if you subtract it, then that quantity will give us the time. Okay, so it is the interval between two events. It's called time. Okay. And the units of time, generally units of time, first one is our solar day. Solar day. So what is solar day? The time taken by the earth to complete one rotation about about its own axis is known as one solar day. So write the definition from the book. Okay, so definition is homework, you can write it through the book, page number 4. Okay, and similarly we have mean solar day. So mean solar day, mean means the average. So that means the average of the varying solar day when the earth completes one revolution around the sun. It means, or it called as mean solar day. So you write the definition of B also, and the last one is our hour. Okay, so again is mean solar day, then last one is our hour. Okay, so 1 hour is the 1/24th part of the mean solar day. So after finding the mean solar day, if we multiply it by 1/24, then that will give us our 1 hour. Then we have minute. So minute is the 1/1440 part of the mean solar day. Similarly for second, it is 1/86400 part of the mean solar day. Okay, then we have year. It is the time in which earth completes one complete revolution around the sun. If the earth completes one revolution around the sun, then that time is known as our 1 year. And decade. Decade is the 10 years of 10 years of time. Means 10 years. After 10 years, it's said to be one decade. Okay. Then millennium or century. First, we will discuss about the century. Century is our the 100 years of time. So if it pass 100 years, then we will say it is 1 century. And for 1000 years, we will say it is has to be millennium. So write all the definitions. Okay, till page number 4 above the exercise 1. So complete it and send me the notes in WhatsApp. Okay, thank you.